Hello everyone and welcome to this video looking at the Maths IA, the exploration. This is your one piece of coursework for your Maths IB course. It's worth 20% of your grade and it seems to be causing a lot of people a bit of a headache. So I'm going to try and give you some insight today that I've garnered throughout my years of teaching the IB courses. I've marked hundreds of these things. Some I've given 20 and some, well, less. So I just want to have a quick dig into it in today's video, give you some of the headline ideas and hopefully try and give you some advice. So here are the things I'm going to look at today. The exploration is an exploration. That's a really important thing to remember. It's probably unlike anything you've ever written before in maths. We don't do much writing in maths. We tend to just solve problems. So we're going to have a chat about what that means. I'm going to talk to you a little bit about how best to choose a topic, what pitfalls to avoid, and how the IA is marked. Obviously very important. So first up, it is an exploration. Now, what this means is that you need to explore some maths, and it has to be about the maths. A lot of people accidentally try and write about, a particular phenomenon, or they'll try and look at a correlation and they end up writing about things that aren't the maths. So the way I tell my students often is to think of it really in one of two ways. I've written three here, but first off, you can use maths to solve a problem. Now, this doesn't really want to be a kind of common maths problem that you might find in a textbook. This wants to be something more from your real life. Something, maybe a question that you have, something you've thought about, and you wonder, how can maths help me solve that problem? And this could be anything, right? It could be, how do I pass level 17 in Angry Birds? It could be, what's the best stick I can throw for my dog? It could be, what shape should I build the den at the bottom of my garden in the rain? Anything that you can see an application for maths in. The trick here is you might not know what maths you need as you start, but we'll get back to that in a little while. So you could have a problem that you want solved and you write about how maths is going to do that for you. Secondly, you can see how well maths can model a situation. So you could decide you want to have a look at, I don't know, the price of Bitcoin over the last 2 years, and you want to look at how well maths can model the price fluctuations. Now, here's the important thing. Don't fall into that trap of writing a lot about Bitcoin. It's not about Bitcoin. It's about the maths that you're using. Now, obviously you could do all sorts of things there. You could model the price of Bitcoin. You could look at where Bitcoin comes from. But again, if you're not careful, you'll fall into that trap of description, not analysis. That's an issue that comes up in a lot of your IAs, your EE as well. Don't just describe, analyze. So those really are the two that I recommend students think about. Either use maths to solve a problem or look at how well maths models a situation. The third you could perhaps have a go at is look into the development of a field of mathematics, seeing how it's changed over the years. So think of something like cryptography, code breaking, that kind of thing. How's that changed with the advent of computers? How has it developed? What might quantum computing do for that? So you could look at something like that, but again, it's quite difficult to shoehorn the analysis in there. Okay, on to your choice of topic. Now, there's a lot of pitfalls that people fall into here, I guess. I think people are looking for a silver bullet, right? You're looking for me to say, oh, you should write your IA about this, but that's not really how it works. Good IAs are always quite personal. They're something that you know about, something that you enjoy. And the reason for that is if you really know about something, so let's say you're going to talk about shooting a hockey puck. Now, I've never played hockey. I've never done that in my life. So when I find something in the mathematics, I'm not going to really be able to relate that to the example because I don't understand the example. So I'm sure someone else could write a wonderful IA on that. I couldn't. So you've got to make sure you pick something that is personal. Now, people mistake this with, I guess, the personal engagement thing. I think people tend to think that they can get a lot of personal engagement marks by saying that they really, really like something. You know, I've been a big fan of soccer since I was 4 years old, right? That's not going to score you any points. The benefit of choosing something that's personal to you is that you know all about it. And then when the math throws something up, you can relate that to the example because you understand the example so well. So it's not just about saying that you love something. That's not how you get your personal engagement. It's about your knowledge of that thing, right? Really important, that one. Then when you're thinking about what topic you can write, the other thing, I see a lot of advice online given where people just say, oh, do optimization, or do this piece of maths, do some calculus. Again, the difficulty there is if you start with the idea of the maths you're going to do, it ends up with quite a false fit. Remember, we want to explore this idea of kind of uncovering mathematics. So choose a topic that is personal to you, but also try and choose one you can see where the maths is coming, right? So as a sort of a quick example, one of the things the IB suggests that you do early on in the process is this kind of mind mapping exercise, right? So let's say, I thought about this the other day when I was out walking my dog, and I thought, like, what would be the perfect stick for my dog, right? This is a frivolous question, obviously, but it doesn't matter. You don't have to change the world here. You don't have to conclude anything amazing. Just something that's interesting. What would be the perfect stick for my dog, right? Like, I don't want it too long. I don't want it too short. Is there something I could do about, length there? That gets me thinking about kind of distributions, the normal distribution of sticks that I find. Maybe I could collect some sticks on my walk, do some sampling, see if it fits the normal distribution. Who knows? Not loving that idea, doesn't sound brilliant. What about sort of things around density or mass or weight? Some sticks are just really light, can't throw them very far. Others are too heavy, not going to be able to throw those. What about the shape of a stick? Now, my dog is an idiot and he likes to carry his stick with the end in his mouth, which is stupid because if it catches on something, he's going to get poked in the mouth, right? So what I want for the end of my stick is not for it to be this sort of jagged stick end like that. I'd like a kind of a nicely rounded off end. So is there some way that I can measure roundness? Like, how would we measure that mathematically? So now we're into something where we think, okay, I've got a problem. How do I pick a good stick? Is there a way that maths can help me answer this problem? Is there a measure for roundness? Right? Like, can I take a shape like this and a shape like this and mathematically compare them? To my eye, the second one I drew is rounder. How do I measure that mathematically? Is there a way? Perhaps there's some sort of well-defined method already out there, or perhaps I have to kind of make one up myself. Just glance at them, maybe I could do something along, kind of learn a bit of polar coordinates and look at sort of charting this distance as my angle theta is turned around this point and measure the eccentricity in this length, how it's changing as theta wraps round. Perhaps I could do something like that. Certainly I can graph those lengths. Perhaps I could look at kind of correlation. I can see ways that I can begin to use maths to answer that problem. So definitely do this, right? Start from anywhere, just something frivolous like throwing a stick for your dog, and think, okay, what maths goes in here? What maths can I find? Right? If I can find 2 or 3 quick ideas like that in 2 minutes about throwing a stick for my dog, you should be able to find these ideas for your subject. That kind of brings me on to some pitfalls. So as a teacher, and you have to remember your teacher is going to mark this for you, just stop writing about basketball shots. It's the most boring IA in the world, right? Oh, I throw the ball as a parabola and it lands in the hoop, and oh, what angle shot? So boring, right? If I'm bored when I'm reading your work, I'm not going to give it a good mark. Like, you can say that's unethical and your teachers should give everyone a fair show, and we do. But think about when you're doing your schoolwork, right? If you're doing something that excites you, you're passionate, you care about it, you do a better job. If you're doing something you're bored by, I'm not going to go looking for marks here. I'm just going to be a bit disappointed that my students have ignored my advice, because I definitely give them that advice. I'm going to say stop Googling, right? you know, stop Googling things like best IA idea, right? It has to be personal. One student could write an amazing IA, another student could take that same idea and do a horrible job. It has to be down to you, not just your interests and the things that you know, but also you've got to pick something you understand. There's no point throwing in second order differential equations when you're doing SL maths if you don't understand them, because you will end up writing something that doesn't make sense. We will sniff it out and we will know that you don't understand. It's painfully obvious. When someone has used some maths that they don't really understand, it is painfully obvious, and we have no choice but to penalise it, really. Right? Because you have to show you understand the maths you use. Sometimes people think that the maths score, we'll get onto the criteria in a minute, people tend to think that the maths score is about how hard the maths is. Not at all. We'll come back to that in a moment. Do the maths first. This is really, really important, right? So many students, you know, when they get into a bit of a panic with their IA, they bring them to me and say that, you know, they need a bit of help. They've written all this stuff, and then they've arrived at the maths point of the IA and gone, oh, it doesn't make sense. Or, oh, I don't have a correlation. Or, no, there isn't a method to measure roundness in maths. It doesn't work. And I mean, look, that's fine, right? You've got to break a few eggs to make an omelette. But do that bit first. Play around with it, see if the maths works. Once you've got the maths working, then go and write your introduction and your rationale and all that stuff, right? But play around with the maths first. So avoid those common subjects, right? Basketball shots, correlation between GDP and life expectancy. These are just really expected common problems. Avoid them, right? It's all good and well looking on the internet for examples, so you can see examples of really good IAs, great, but don't expect that to do your thinking for you. Build this thing yourself from the ground up. I guarantee that's the best way to come up with an IA. Pick something you understand. Don't be tempted to do crazy difficult maths. It doesn't get you bonus points and risks you showing that you don't understand it. If you want to go and learn some extra maths, you know, lots of students have had success with me, for example, learning about graph theory. It used to be one of the HL options. It's not really taught anymore. I think there's some in AI. But you can learn graph theory. It's not that difficult. You know, things like Eulerian trails, stuff like that. And that would make a good IA. You know, I had a student who wanted to visit all these different streets in Wanchai where he lived. And you know, it was pretty good, pretty solid IA. He taught himself some graph theory. It's not that difficult. So he was able to properly understand it, not just throw it in for fun. And like I said, do the maths. You've got to make sure the maths works before you get any further. Now, onto how it's marked. You'll have seen this criteria, hopefully, when your school introduced you to the IA. They're out of 4, 4, 3, 3, and 6. What this means is you can get an awful lot of marks just for presentation and mathematical communication. This is just, do you have an aim? Do you have a rationale? How well does it flow? I advise all students to get a peer to read through it and just see if it makes sense. Your audience for this piece should be your peers. You shouldn't need to be some sort of mathematical savant to understand your work. It should just make sense. Is everything explained well? Right? Do you tell me what you're going to do before you do it? Do you reflect on what you've just done? Are you telling me what's coming next? So just how you would write a nicely flowing essay in English or for your EE, think about those same things for maths. You learn about PEAL paragraphs in English, PEAL, point, evidence, analysis, link. Use that in maths, right? Write well. Mathematical communication, the number of IAs that just get handed in without axes labelled, without variables defined in equations, without using a proper equation editor to put things in, and they all look weird. Why throw these marks away? These are the easiest marks to get. We get onto criterion C, that's personal engagement. Remember, that's not just saying, oh man, I love football. It's about making the maths your own. And again, what that comes down to is you're writing about something you really understand. So if you're writing that hockey IA and you find out that there's some sort of, I don't know, second or third order derivative cropping up in the equation. Now, that I can't make sense of that. Maybe it's about, does the stick bend when you hit the puck? I don't know. But you would if you know a lot about hockey. So you can show your personal engagement by making those clear links between what the maths is telling you and your understanding of this thing. Also, any extra little things you can do to push it over the top, you know, perhaps a little bit of, it's a bit of theatre, but something, you know, where you can do an experiment or collect your own data. For example, I had a student, I had a student write an essay, write an IA once on how CSI teams use the cooling of a body to put the time of death when they discover a corpse. It's a bit macabre, but you know, it worked. And they decided that they would heat a chicken in the oven to body temperature and then see how that cools over time. Now, did it really add to the maths too much? Maybe not, but a little bit of theatre just shows they really are engaged with the work. This isn't something they've just grabbed off the internet. They've written this themselves, they've done it themselves, and it does help. Reflection is also really important. You'll be sick of reflection throughout your IB, I'm sure, but especially here, we want you to reflect on the maths. So I've had a look at the end of my stick and I've come up with this method using polar coordinates. What has it taught me? Has it taught me anything about the problem? Like, well, yes, there is a way to measure stick roundness and I can apply this to the sticks I find out on my walk. But also it's taught me that mathematics can come up with ways to measure all sorts of things, and that finding novel ways to measure things is a big job that mathematicians do. And maybe I've learned something else about how valid these methods are. Perhaps my method worked really well in some scenarios but didn't in others. I've learned about the limitations of my method. I might have some ideas for how to improve my method in the future. So all these things need to go in. I would generally encourage students not to leave reflection to the end. Don't just like write a big page at the end. Try and do it as you go. So one model I always kind of talk to my students about doing is when you think about a mathematical process, so let's say you're going to do the chi-square test for independence, start off by telling me what you're going to do and why you're doing it. So I'm going to do the chi-square test for independence. I'm going to see if these two things are independent, or maybe I have enough evidence to reject the idea, and that might suggest there's something going on. Then do the chi-square test, lay it all out properly, signpost everything, label everything, have your tables carefully laid out and justified to get your mathematical communication up. Then at the end, tell me what you learned. What is the significance of this value is higher than this value? What does that mean? How does that inform your original question? And then what are you going to do next? In some ways, that's the Peel paragraph again that we talked about earlier. You've got a point, you've got some evidence in your analysis, that's the maths part, and then you're going to link it to the next thing you do. Nothing should just sit in isolation. Everything should have a purpose. Everything should inform the original question, and you should reflect on what it's taught you. And finally, use of mathematics. Again, this idea that now this is the only place where the IAs diverge. So standard level and higher level, the IAs are basically the same. This is the only place that they diverge, and you can read through the marking criteria at a later date. We'll do another video looking at that. But this is the only place they diverge. Now, you don't get bonus points for hard maths. It's a fact. All you have to do is have maths commensurate with the level of the course. So if it's maths that's listed in the topics of your textbook, and it's not a presumed knowledge, that first chapter is sometimes presumed knowledge, so long as it's one of those chapters, that's commensurate with the level of the course. Doesn't need to be super hard. But you do need to show knowledge and understanding. So this is about all those little things you write about the maths. This is about how you apply the methods. This is about what you conclude from the methods, right? You can just go and copy stuff off the internet, right? You can come up with a proof or a derivation of some complicated formula that you just found off Wikipedia. Great. I mean, it can go in the IA, but it doesn't really show knowledge and understanding. So if you are repeating a proof, make sure you explain every step, right? Show that knowledge and understanding. Really, really important. With the HL, there is then the emphasis on this being a bit more sophisticated. People sometimes take sophistication to mean difficulty in maths. That's not really it. But you are going to want to choose something that at least has a little bit of meat to it. If you do go overly simple, while still commensurate with the level of the course, you're perhaps not going to be able to show off that deep knowledge and understanding, right? I mean, it's not that impressive that you understand a triangle has 3 sides. You've got to show knowledge and understanding of at least some fairly sophisticated concepts within the course. But that's it. Don't be tempted to go too far. You don't get bonus points for going outside the syllabus. You just don't, right? And my last word of advice really is, don't forget this is marked by your teacher. It is marked by your teacher. Well, perhaps under the last couple of years of COVID strangeness, it's been a little bit different. But we mark it, and then our marking gets sent off for moderation. Now, I think there's a misconception sometimes that means that the moderator remarks your IA. That's not what happens. They are marking my marking. So if I write, I'm giving the student 1 for personal engagement because I don't think they were especially engaged throughout the process, and really they've gone against my advice and just written a boring IA that I counselled them not to. Now, I would never write anything that harsh. I'm always in my student's corner, but your teacher could write that. There's no way IB are going to overturn that one, right? I mean, obviously, unless your IA is completely different to that. So they are marking your teacher's marking. And that's good because your teacher can then, if one year they discover that they've been overly generous or overly harsh, they should be adjusting their marking for next year. And all the teachers are working really hard to do as fair a job as we can with your marking. Please don't get confused about that. We really are. But if your teacher says to you, don't do that, it doesn't work well, listen to them. They're going to mark it. Don't think you know better. Maybe you're right, but it doesn't matter. It's about getting points, isn't it? It's about scoring well on your IA. So listen to your teachers. Any advice they give you is the right advice, right? They are going to be the ones that mark it. Now, if you've got the worst teacher in the world, perhaps you need to take my advice there with a pinch of salt. I like to think most of my colleagues are doing a good job, but I would definitely say don't forget it's marked by your teacher. Right, so that's it for the first video here. I just wanted to get a few kind of basic ideas out there, introduce some of the thoughts I have around the IA. I'm going to be following this up with some other videos looking at how to set out your IA and how to maximize those mathematical presentation points. I'm going to be looking a little bit more at use of mathematics, and I'm going to be looking a bit more at how we can improve reflection, personal engagement, and hopefully take you through some examples of how I would develop an idea from the ground up and make sure that I'm maximizing everything as I go. But that's it for this time. Thanks very much for watching.